Hi, so in this video, we're going to be looking at how to derive the equations of motion that we keep seeing in AS level physics in the chapter on kinematics. The four equations are given right here, and we're interested in seeing how these can be derived. And that's pretty important because it's explicitly a part of the syllabus. And on the right here, you have a velocity time graph, which shows a very simple motion that's representing uniform acceleration. Let's briefly look at what it's showing us. So the object starts off at some initial velocity u with the time 0, and then accelerates uniformly as shown by this straight line graph. And when it accelerates, it goes from an initial velocity of u to a final velocity of v, and it takes a time t to do that. So that means it's accelerating uniformly, and it goes from a velocity of u to a velocity of t in a time that we're referring to as t. Now let's see what we can derive from this graph shown right here. The first thing is that the gradient in this case represents the acceleration. And the gradient, we all know, is given by the change in the y quantity divided by the change in the x quantity. The change in the y quantity is just v minus u divided by the change in the x, which is just t. So we're basically done. If we simply rearrange this equation, so you rearrange a is equal to v minus u over t. And if you do that and make v the subject, you get v is equal to u plus at, which is basically the first equation right here. Now let's look at the second one. One other thing that we can obtain from the graph shown on the right, and perhaps we can label this. So the second thing we can get from this velocity time graph is the distance or the displacement, which is the area under the graph that's been highlighted in green. And how do you do that? If you want the displacement in this case, you find the area under the graph. Which in this case is going to be 1 over 2 multiplied by the sum of parallel sides. So what are those? One side is u, and the other side, the parallel side, is v. So it's a sum of the parallel sides, u plus v, multiplied by the height, which basically means how far apart the two parallel sides are. So this is the distance between the two parallel sides, and that's equal to t. So this is what we get. That means your displacement s is given by 1 over 2 times u plus v into t. So we're going to be making use of this equation right here to derive equation number 2. But before we do that, let's just actually look at what this equation actually means, or what it's showing. So in order to do that, we're going to write it a little differently and say it's u plus v over 2 multiplied by t. Now this term right here, u plus v over 2, the entire term is actually giving us the average velocity. And if you multiply the average velocity by the time, you know it is supposed to give you the displacement. So that's a pretty straightforward equation, and finding it from the graph should also not be any issue. Okay, so now we're going to use this 1 over 2 times u plus v into t to derive equation number 2, which is s is equal to ut plus half at squared. And how can we do that? Well, whenever you're doing a derivation problem, what you need to realize is what are the variables or quantities that you're starting off with, and just, where do you want to go? So in this case, you have s, u, v, and t. But the equation that we're trying to get to has s, u, t, and a. So what's the difference? You see, we have v here, but there's no v in the equation that we want. But instead, there's an a. So that then basically tells you that you need to do something, or you need to come up with an equation that allows you to relate v and a. And of course, we have a very simple equation that does that, which is v is equal to u plus at. So all we need to do is plug in this in place of v. As we just said, that we want to get rid of the v and we want to introduce the variable a in the equation. So this would then become 1 over 2 times u plus the v itself is equal to u plus at. And then this whole thing is being multiplied by the t. The rest is just simple algebra. You get 1 over 2 times 2u. No. Yes. 1 over 2 times 2u plus at times t, which is ut plus 1 over 2 at squared. And on the left, we just have s. So there you go. That's how you derive equation number 2. And just to check, you had 2u here divided by 2, so that it gives you u, multiplied by the t, it gives you ut. Then if you come to this term, it's just at times t, which is at squared, and multiplied by the 1 over 2, it gives you 1 over 2 at squared. So let's cross these out and move on to the next one. Now, if you look at equation 3, it's very similar to equation 2. So if you just compare these two, the only difference is that this has a u, but this has a v. And here we have a positive sign, and here we have a negative. So once again, just by looking at these two equations, I know that I need to get rid of the u right here and somehow introduce the v. And once again, we're going to do the same thing. We use the same equation as we did for equation number 2. We know that v is equal to u plus at. And now we want to substitute something in place of u. So that means we should make u the subject of the equation. So u is equal to v minus at. So now you see I have u in terms of v. And what we're going to do is substitute the u into this equation and get to equation 3 that we looked at above. And that should be straightforward. So the equation that we're going to substitute into is right here. And it is u, which is now equal to v minus at. And then the rest of it goes like this. U times t plus 1 over 2 at squared. And then if you just multiply everything, you get vt minus at squared plus 1 over 2 at squared. And finally, that gives you vt minus 1 over 2 at squared. So it doesn't seem too complicated. We're done with equation 3 as well. And we only have to look at how to get equation 4. Now, before we do that, one thing we want to note is that you'll see that each of the equations obviously is a little different from the other. So over here we have v, u, a, and t, 4 quantities. In this one, we have s, u, a, and t, but there's no v. And then if you come here, we have s, v, t, and a, but there's no u. So you see basically the way we use this equation, so basically you see the way we use any of these equations is that we look at the quantities that are known and then pick one of these equations, 1, 2, 3, or 4, depending on which quantities are known and what the unknown quantity is. All of these equations have 4 quantities in them. So if you know any 3, then the 4th one can be easily found. But anyway, that's not the point of this lesson. So let's just continue and derive this equation right here. So now to do that, once again, we're going to start with this equation. Let's just move this a little lower. Our starting equation is going to be the one we saw for displacement, which we said is equal to 1 over 2 times u plus v multiplied by t. And just to remind you quickly, we said this is the average speed right here, and multiplied, or average velocity multiplied by the time, it gives you displacement. Now, again, hopefully you're making sense of how derivations are generally done. And I want to just elaborate a little bit on this so you can really see how to go about it. So that basically the point is that blatant memorization of derivations is is a very poor way of going about it, because if you forget on the exam day whatever the sequence of manipulations that you had memorized, then you're going to be stuck. But if you have some sort of a method that you can follow, you can always rely on it. There's no question about forgetting a method. So from this, we wish to go to this equation. V squared is equal to 2 squared plus UAS. Now over here, we have S, U, V, and T. And the equation that you want to get to has S, U, V, and A. So you see the only difference between the two is that you have a T over here, but over here, instead of the T, you have an S. Sorry, you have an A. So then, again, what does that mean? It means that you need to find a relationship that connects T and A, so that when you plug in something for T in this equation, the T goes away and the A comes in. And hopefully you can think about what that is. A is equal to V minus U over T. If you make T the subject of the equation here, you get V minus U over A. And all you need to do is take this expression and plug it into the T here. So let's go ahead and do that. S would then become 1 over 2 U plus V multiplied by V minus U over A. Now, just to make it easier, we can pull out the 2A in the denominator because all of these are getting multiplied. So the 2 times the A gives you 2A, and you write it outside the parentheses. And then you just have to multiply this with this. And that gives you U, V minus U squared plus V squared minus U times V. And what does that leave us with? The UV goes away with the UV right here. And we have 1 over 2A times V squared minus U squared. And you can see the rest is just pretty straightforward. This is equal to 2AS. And if you rearrange, it's V squared is equal to U squared plus 2AS. And that is the fourth equation that we were interested in, which is right here. So that's about it, and we're done. I hope it made sense to you and you're able to do this on your own. And in the next video that I upload, we'll be looking at how to use these equations for kinematics problems, especially as they relate to projectile motion.